Solving matrices using row echelon form. You have your augmented matrix and you transform it into the row echelon form where there are 3 zeros at this bottom corner and the rest can be any number. You will find 3 different types of solutions that you can easily see using this form. That is the unique solution, infinite solution, and no solution. The unique solution is where this value right here next to 2 zeros, C3Z equals to D3, where neither of them can be 0. Your Z value will have a unique solution that it possesses only one value. Next is the infinite solution, is where C3 and D3 are both 0, meaning that your row echelon form will have 5 zeros here. 1, 2, 3, 4, 5. Next is the no solution, is where C3 is 0 while D3 is not. You have 4 zeros here and this is not a 0. And you cannot find an answer because it will be 0x plus 0y plus 0z equals a number, which is not possible. Now, moving on to an example. Here we have a system of linear equations, and I want you to try to solve it using the augmented matrix and transforming it into the row echelon form. This system of linear equation has a unique solution. You can pause the video and give it a try, and I'll show you the answer in a bit. And here is the solution. First thing you'll probably notice is why the -2 and 1 are in different placement compared to the question is because they need to have the same variable. As you can see, the first column, these two have both x, but this is not x, so you need to move this over. And same with the y. This one, you have to move it over here, so that each column consists of only one variable, x, y, and then this is z, and this is the answers. The first thing you need to do, I would recommend you to do, is to change the top left corner into a 1. This is to make it so that when you want to make these two values into 0, it will be easier to calculate. And the same goes for the middle value here in the very center. I would recommend you changing it to 1 so that you can easier change the bottom one here into a 0. And as you can see, these two values are not 0 and are unique. So you'll get a unique answer, which is this. Here is the second example, another set of system of linear equations, but this one has no solution. So you can give it a try before you can pause it, give it a try before you continue. And here is the solution. First thing, change the top left corner into a 1, then make the bottom two of the same column into a 0, then the middle one to a 1, and lastly this one to a 0. As you can see, with the final step, the bottom right corner also turns into a 0, but this side is not a 0, which means that this is 0 equals to 11 over 2, which is not possible. So this matrix has no solution. Here we have the last example of the system of linear equations, and this one has an infinite number of solutions. You can try to do it yourself and continue the video later. And here is the solution. First, to make sure that this is 1, which it already is, so we can just move on to the next step, which is making these two values into a 0. Then, making the center into a 1. It's a -1. You don't really have to change it. Oh, it's already a 1. But this is negative. In case if you're prone to making careless mistakes, I would suggest you changing the middle into a +1. And then making the last value 0. With the last step, these two values also become 0. So this whole bottom is just 0 equals to 0. So that means that there is an infinite number of solutions. So these are all the examples I have to show. I hope you found this video helpful. Thank you for watching.